This is the first episode of this podcast series from the RSP SOC, and our first guest is Áine O'Brien. Hi, Áine, and thanks for accepting our invitation.
You're very welcome. I'm excited to chat.
And I hope I pronounced properly your name.
Yes, Áine. The best way I tell people, because my name doesn't look like you say it, is think of on your bike or on your head, and then just take the head or the bike off.
Yeah, thanks for. So I will avoid calling you by name, just to.
It's all right. You did a good job.
So I can start probably with a bold question and asking you, what do you do right now? I heard you are a carbon rating scientist, but if you can tell us more about, your job, what day to day?
Yeah, sure. Yeah, so as you said, I'm a carbon rating scientist. I work for a company called BeZero Carbon, and we are a ratings agency for carbon credits. So what that means is offsets for greenhouse gas emissions. We dig into them and work out what the risks are that if you were to buy a ton of carbon as an offset, so you said, I want to avoid a ton of carbon or remove it from the atmosphere. And we look into is that what are the risks that ton that you've purchased actually doesn't represent a whole ton? So or in other words, as I like to describe it, I'm a greenwashing detective. So I basically dig around, look into offsetting projects. I look into offsetting projects that are from the kind of technology space. So that could be energy, renewable energies, that avoid emissions, or it could also be things that avoid methane emissions. It could be things that actively remove carbon from the atmosphere. So people often hear of carbon capture and storage, like into rocks, things like that. And these are the sort of projects that I dig around into as a scientist and see what are the risks that it might not be doing what it says it's doing, or that it doesn't need the money from someone buying offset for that to happen.
Okay, thanks. And so does it mean you work directly, for example, with the aviation industry, try also to reduce the amount of travel for people? Or is more about, as you say, removing CO2 from the atmosphere? And
from the aviation perspective, the work we do on that side is looking at sustainable aviation fuels. So these are kind of fuels for planes where they use biofuels. So it's a kind of circular economy, or bio waste, biomass waste. So it reduces the emission there from using typical diesel airplane fuels. But we don't directly do the project, so we're not the ones doing the removals. We're like the closest thing to a regulator. So my role is to look at, and we're very much independent. So projects that exist to remove or avoid carbon, we are the ones that look into them and provide an independent assessment of how effective they are as a carbon offset.
Okay, thanks. And now trying to go, let's say, back in time, following your career. So now you are, carbon scientist, but your background is mainly on physics and astrophysics. How the two things are connected, if they are. And also, I think you started, I saw on LinkedIn, you started with a proper physics course in Leicester, and then you end up in Suffolk. Then you have been working also as a Brexit analyst, and then you started a PhD on meteorites, essentially in Glasgow. So how all these things are connected together, if they are?
Yeah, great question. And I have had a very varied career. So as you said, I started off my undergraduate degree with physics and astrophysics, and then I was a high school teacher for 3 years. So I taught physics in a school for 3 years. And when I was a teacher, I loved it. I loved, engaging with students and seeing kids get excited about science. But I started to kind of get jealous that the kids were learning new stuff and I wasn't. I really missed doing new stuff myself and learning new science. And that's why I decided to go back and do a PhD. And my PhD was looking at meteorites from Mars, but I was looking at the carbon in the rocks from Mars and trying to understand if Mars had the right ingredients for life to form, because every living thing on this planet is based on carbon. So I did that PhD, and yet one of the things I did during lockdown, I couldn't carry on my experiments because the university was closed. So I did a remote working placement, because at the time, all the Brexit negotiations were happening, and it was very clear that in the space industry, we really didn't know exactly what was going to happen, because in Europe, the space sector is very interconnected, particularly in the European Space Agency, which we are still a part of after Brexit, but there are companies where they have their supply chains across multiple countries, the UK, then France and Italy, etc. And it was still a constantly rapidly evolving situation of what was Brexit going to do to that, what were their risks, etc. So yeah, I did basically a sort of policy placement to write a kind of commercial report, kind of looking into what the risks are of Brexit. And then, so then I went back to my PhD, finished it once the labs were open again after lockdown. And then I worked as a postdoc, so as a university researcher for a year, using the same kind of techniques that I'd done in my PhD. So looking at rocks from Mars for carbon. Instead, for my postdoc, I was looking at rocks on Earth for carbon. But the carbon I was looking at was basically soot from ancient wildfires. So I was developing techniques that you could effectively predict what happens for future wildfire severity, like basically how hot are they, how fast are they going, how big are they, etc. And predicting that by looking in the past at when the Earth was much hotter in the past, and trying to see in the geological records, so going back deep into rocks from periods of time when we know it was very hot, and seeing, can we look at individual particles of soot from that time and understand from that, basically, when a fire is at a different temperature, it has a different kind of soot. And that's as simple as that. It'll have different molecules if a fire burned at 800 degrees C versus if it burned at 600. So I did that for a year, because I really felt that whilst I love space, I wanted to do something more important for the planet. And it was at that point that I found out about BeZero. So after I'd been there a year, and it feels like a great mixture of, a lot of us are scientists with PhDs. I'd say about 70% of the scientists in the company have got PhDs, and we've all got very different backgrounds. And what's really nice for me is, and this is very relevant for yourselves as the RSP SOC, is that a big strength of BeZero's is our remote sensing. So we need Earth observation to do a lot of our analysis. Particularly in the nature side, so using satellite data to monitor forests, to monitor fires. From my side, which is the kind of climate technologies rather than the nature side, I love to use remote sensing. It's one of my favorite things about my job, to essentially look for mass emissions of methane. So methane is a greenhouse gas, which is 28 times as powerful as carbon dioxide. So the effect is 28 times worse effectively. And there are more and more missions and spacecraft coming out these days that are using, that are able to detect methane leaks. And that's one of the great things I like to do in my job, is look at methane emissions that you can then avoid. Once they're detected from space, you can then say, okay, we're going to do an intervention to stop that, and then they will then there will be carbon credits for that intervention to say we have avoided the emission of this many tons of methane by doing, whether it's capping an oil well, or whether it's for instance burning a landfill gas, a landfill that released methane, it burns it instead to generate electricity. These are the sorts of things we look at. And that, for me, it's great because that's using my background in astrophysics as a space scientist. I was looking at carbon on Mars, and now I'm just looking at carbon on Earth, but using space technology to do so.
And so this will bring me to my next question: is how much of what you learned during your academic career has been, let's say, useful for what you are doing now? or it was more something that you learned by yourself on the job, let's say?
Great question. Yeah, I'd say my PhD, and I would say most of my colleagues who've done them as well, there are real technical aspects. You know,
Okay.
for me, a lot of my PhD had like aspects of carbon in there. My undergraduate degree as a physicist, a lot of what I look at in this job is energy projects. So I have a good understanding of energy generation, etc. But what I would say is really more than anything, the way having a PhD has lined me up for this job is how to be a scientist. So
Okay.
a big part of my job, like I said, I'm a greenwashing detective.
It's the mindset.
What I mean by that is it's like digging around, having a sixth sense of if something doesn't smell right, if there's been a project claim that maybe doesn't have the most evidence, I'll go look for more evidence. And those are the sorts of research skills that I think you get from a PhD, because you really probe away at something, you pick away at it, and you think, okay, here's a question I can ask. I'm going to go away and find some answers, find databases. Also, really crucially, it's being comfortable to handle data. So I love a spreadsheet, I love a graph. There's nothing I like more than spending ages, whether it's on QGIS, which is a mapping software, making pretty maps, or whether it's making nice graphs that tell a story. You know, as a teacher, I want to communicate. As a former teacher, communicating science is my jam, and what I like to do is communicate that through graphs, through maps, etc. So I guess that's how my very varied career all comes together.
Okay.
Because it's communicating science and doing it in technical, fun, interesting ways.
And basically, especially probably during your PhD period, and more in general, I would say as astrophysics, do you tend to spend a lot of time in the lab? Just because the idea most of people, and myself included, will have is probably you are a proper nerd, spending all your time in a lab, looking at spreadsheet, like you say. Is that the case, or?
Yeah, in my PhD, I did have a few bouts of lab work, which were really enjoyable. Those things, I got to go all over the world. So I went to Washington, DC a few times. Part of that was to work with the Smithsonian Institution, which is a big famous museum in America. And they've got the world's biggest meteorite collection. So I got to spend 2 weeks behind the scenes in the American Museum of Natural History, going through their collections of meteorites and studying those. I also, there's a place called Diamond, which is basically a giant metal donut in the Oxfordshire countryside, which is a synchrotron. So people think of the Large Hadron Collider at CERN, it's a massive metal donut in the Swiss and French Alps, but we have a smaller version, if you like, where particles whiz round at high speed in Oxfordshire. And during my PhD, I got to go there because one of the byproducts of this really high energy metal donut of these particles spinning around is that it produces X-rays. And I got to use those X-rays to fire X-rays at bits of Mars to try and understand what it was made of and what these carbon molecules, what their structures are. So yeah, definitely a lot of lab work. I found that really enjoyable. I also got to, because my PhD was all about meteorites, one big thing we want to do is collect them. So we want to retrieve them when they fall to Earth. So a few times in my PhD, I was lucky enough to get to go out on field work to basically go look for meteorites when we've detected them falling in the UK. So that's another side of remote sensing. You can do remote sensing looking down at Earth, but we also have cameras in the UK that look up. And that's entirely to try and spot meteorites as they fall to Earth and then triangulate them. So if you've detected a meteorite from more than 3 cameras, or at least 3, there are some very clever wizards who can do some very hard sums and constrain the likely fall zone to within normally about 1 kilometre squared or so. And there'll be a team of us who'll go out into the countryside and search for those. And we were lucky enough, actually during lockdown, to find the UK's first meteorite in 30 years, which is amazing to be a part of. I was there. There was one that fell on famously on the driveway of a family, but that rock itself had fragmented as it broke up, as it was falling through the sky. And the biggest intact piece of it fell into a sheep field, and there was 4 of us who were the ones who found that, and it was just like the most joyful moment. And that piece is now on display in the Natural History Museum in London. So that was amazing. And then I also, within 2 weeks of it falling from the sky, I was in the lab studying it, so we could find out what it was made of as well, which is really cool.
Wow. Well done. I didn't know about there were meteorites coming down in the UK.
Yeah.
Silly question. Do you pay for having meteorites? For example, this one from the US. I don't know. Are you able to bring them to the UK, or you have to go there inevitably? And eventually, can you get a sample for free? Or
yeah, really good question. And it really depends on the country. So every country in the world has different rules about what happens when a meteorite falls.
okay.
And beyond that, it depends on where it falls. So in the UK, if a meteorite falls on a person's private land, there's no actual official law, but the way that it's treated is as if it's treasure. So in the UK, if someone's and treasure by which would mean like archaeological treasure. So if you were to find, or if I were in my back garden here in Scotland, if I were to dig up, I don't know, a Viking crown, let's say, I'm pretty sure that doesn't fit into history, but you know, some kind of ancient treasure, it would be mine, but I would be able to sell it if I wanted to, or if I could give it to the UK's, essentially our museums. And that's the kind of typical thing that happens in archaeology is one of the big British museums will pay for that. And obviously people don't have to say yes, but the thing we hope to do with meteorites is that a person will happily donate it. But indeed, the Natural History Museum will always offer, they'll say, we'll pay you this much per gram of a sample.
Okay.
That said, people can also keep it. And therefore, there is actually a pretty major like meteorite trade internationally, private trade. Like you can go on eBay and buy a meteorite. That will really depend on the country that it's fallen in, because in some countries, like I think Australia, wherever it's fallen, it is automatically, and maybe it's certain Australian states, like I think it depends on the state. But in some places, if a meteorite falls, it is automatically, it belongs to that country, like to the government, to the state.
Okay.
So it really depends. So there are some that I studied in my PhD where the university had paid for a sample. So a couple of grams might, you know, especially Martian meteorites, they're expensive. We're talking thousands of dollars for 1 gram because it's so rare and they're so in demand. But also there are ones you can apply to use for free. So NASA has a whole chunk of them. You just have to make a scientific case for them to give you a little bit. And that's a skill as well as a scientist, is being able to communicate the importance of your research to somebody like, for instance, NASA or the Smithsonian, and say, here is what I want to do with this. Here's how much we're going to learn from it. Will you give me a tiny piece of Mars, please, basically?
Okay, wow. And then, of course, you have to return it.
Well, it depends on the analysis. So everything I ever did in my PhD were things with tiny little pieces, but they would then, you know, be destroyed effectively.
Wow. Hope it was useful at least. In talking about meteorites, because I don't know if during your PhD or postdoc, but I mean, for sure you received the Barry James Award, I think, for your studies on the Winchcombe meteorites. But you've also been solving a mystery about the Lafayette meteorite. So I have to read the story behind. But I think I saw and I'm reading now the BBC title on one of your, where you talk about this meteorite, and the title is Pig Vomit Toxin, Key to Martian Meteorite Mystery. So what happened there?
Yeah, you've really done your homework. Yeah, it was really fun. And this is where, you know, when I say my job now is being a climate detective, you know, part of my PhD, I would say I was a meteorite detective. So similar things, it's having a good sniff for science, a good story, if you like. So yeah, this all happened by accident, really, during my PhD. I did a experiment where I basically took a little piece of Mars, and this meteorite was a Martian meteorite called Lafayette, and I dissolved it and put it through a machine called a mass spectrometer, which can tell you what all the organic compounds, so the carbon-based compounds, were that were in there.
Yep.
And I did this just before lockdown. So I did the experiment in early 2020, I think I got my results in early 2020, and was starting to look through them. And I basically had a massive database of compounds, of molecules. And I didn't know where to start because there were thousands of them. And I'm an astrophysicist. Like, my background is not as a chemist, an organic chemist especially. I finished chemistry when I was 18. So all I'd started to do was just just look through this list of molecules that were in there. And one of them was called vomitoxin. And I just thought, that's funny. That's a molecule called vomit. And this was, I think, the second week of lockdown at this point.
You did a lot during lockdown, eh?
Yeah, I did actually. Looking at the time, it felt like not much, but yeah, it's nice looking back and feeling like it wasn't all just being terrified and doing quizzes on Zoom. So yeah, it is nice. Anyway, so I looked this up, and I found out that vomitoxin is a sort of toxin that's produced by a fungus that is only found on crops, particularly wheat and corn. And I just kind of happily, casually mentioned that to my PhD supervisors. I was like, isn't this funny? Like, maybe it fell on a farmer's field or something. And that's when my supervisors told me that this meteorite, actually, no one knows exactly where it came from. It was found in a drawer one day in a university in the States. But the history before that was really uncertain. And so my supervisors said to me, Áine, why don't you just see if there are any records of that disease in that state? So this university was Purdue University in Indiana in the US. And I just thought, yeah, that's cool. That gives me something to do when, the world was falling apart. And so basically I just did some sleuthing. So I looked into records from the University of Purdue and from general like archives, etc., all across that state, to see if I could find any records of the disease. And I found out there were 2 years where this thing was particularly, like, there was loads of it in the region around the university. And then I read what was the little we did know, or the little records we did have of the meteorite, and the person who found it in this drawer. So what the story was this was like 1920s America, 1920s, early 1930s. And the story was that in this department, a Black student in the university had been fishing when he found this interesting rock, and he'd handed it into the university. And they thought, because when meteorites come through the Earth's atmosphere, they kind of burn up, right? And sometimes when that happens, they get a sort of an exterior that looks like it's been scratched, like it's got like lines, almost like a shell, like going over it. And this one had that really clearly. And what the university thought was, oh, it's something from a glacier. So if you imagine when a glacier goes through a mountainside, it scratches the rock. They thought that's what this rock was. So they just put it in a drawer with a bunch of other samples that were from some kind of glacier. But then however many years later, and that was never known because it was too long for them to remember exactly, someone found it in a drawer and said, no, that's a meteorite. And by that time, the name of that student had been forgotten.
Wow.
And it just said a few years earlier. And then the guy who recognized it died soon after, and his notes went missing as well. So what I then did was think, well, this is 1920s America. I wonder if there weren't very many Black students because, it was a very racist society at that point, and it's a very rural area. So I contacted the university and said, like, hey, by any chance, is this a sort of, like, are you interested in this? It was especially because it was, by this point, I'd gone quite far, and it was the summer of 2020 when all the Black Lives Matter stuff was happening, particularly pertinent. So it was really, it felt really important, because I was like, wow, this could be, we could maybe trace the person who found it potentially. So I contacted the university, an old colleague of mine who was now a researcher there. She got in touch with a librarian who'd actually been, because of all the Black Lives Matter stuff that was happening, they've been looking into the Black heritage of the university, and they've been going back through the college yearbook. So every year in the university, they had photographs of every single student. And they'd been able to go back to those 2 years where the disease was like around. And they went and found all the Black students who were in the university at the time, and it narrowed it down to like 6 people who we think could have found this thing. So it was pretty amazing. And like, because literally there were 1 year there was only 2 Black students in the whole of the university, and the other year there were only 4, which is like horrific, but it does at least make it amazing that there is this bit of like Black heritage there, that one of these students very likely was the one who found this meteorite, which is a piece of Mars. And it's not just any piece of Mars, like it's beautiful, it's really unique. It's now a massive piece of actually the heritage of the university. They had a big thing to kind of mark what an important piece it is. So, because Purdue University itself just so happens to be a very space heavy university. Loads of the astronauts went there. They have loads of people who go there to then go to work for NASA. So it's like an important part of their heritage. And now they have this extra piece of the puzzle, which is, we think it was found in either 1919 or 1927, I think, but I could be wrong with the exact years there. It's a while ago since I did this study, but it was lovely because when we published it during Black History Month in the UK, which was great because it was being able to center it on, you know, these people. It's their story, really, as far as I'm concerned. Like, this is a thing that I did to uncover a little bit of history, as well as it being important for science, because as scientists studying meteorites, we really like to have the context of where it fell, because it's going to have been contaminated if it's fallen in a pond.
So do you think, but this is more probably personal, what do you think? It's probably that meteorite was forgotten because there were Black people who found it?
I mean, I could never know for sure. But from what I read about that time in America, part of me thinks that the find was dismissed and yet forgotten about, probably because of the treatment of Black people at that point. Yeah.
Okay. And yeah, I think, as you say, it's detective work.
Yeah.
I mean, quite astonishing, digging up something from almost 100 years ago. And now that you made the link with minor communities, I also saw you have been an advocate for minor communities, and you also published on Nature something about the bullying and bias against minorities in the astrophysics and geophysics. So, I mean, if you can comment something from that finding, but also my other question is, of course, personal, if you don't want to answer, did you directly experience something on yours? I mean, because, for example, you are female, so do you think you experienced something like this?
Yeah, sure. So to speak to your first question, yeah, this was a paper I published recently after I worked part-time for the Royal Astronomical Society, where we did a survey of astronomers and geophysicists about their experiences of bullying and harassment. And myself, along with a team of other people associated with the Royal Astronomical Society, basically crunched the data and found that if you are from a minority or underserved background, so that's women, but in particular LGBTQ plus people of color, disabled, also age as well, the younger you are, all these factors massively increased your likelihood that you would have been bullied and harassed in research or in science. These things happen at conferences, between supervisors and PhD students, etc. And yeah, it was pretty stark, to be honest. It was something like, if you're a woman, you were something like 50% more likely to be bullied. I think it was 40% more likely if you were LGBTQ plus and disabled, similar. And even anyway, like, without taking into account any of these demographics, I think something like 44% of people had been bullied in the past 2 years before they did the survey, and this was a sample size of about 650 people, so it's statistically significant for sure, and almost half of the community reported being bullied. So it was like very stark, and but very important work. And yeah, we published it in Nature Astronomy. They actually reached out to us. We were doing it as an internal RAS report.
Okay.
But they said, look, we really want you to comment on this in Nature as well, which was really great to get that extra exposure. Yeah, you asked about, is this something I'd experienced? Yeah, I would say, whether it's myself or as well as seeing other colleagues, I've definitely found that the world of conferences is one of the most challenging as a scientist, at least in the academic world. It seems to be the kind of situations where like bad behavior is enabled by the alcohol and big groups and just all sorts of power dynamics. So yeah, I won't go into details, but I'd certainly where I felt really uncomfortable. And then when I've seen colleagues who've had experienced much more severe things than myself, it's something I really cared about. So I was really honored to be able to get that piece of work out there and highlight the sort of things we need, the structural changes we need, to get rid of the power dynamics, particularly the student supervisor relationship. I think there needs to be more protections in place for students so that these things don't happen.
Okay. Wow. But do you think it's, situation is getting better? And also, do you think that, for example, people now talk much more about this issue that probably before they just left as, okay, standard practice?
Yeah.
Do you think?
Yeah, you know what? I don't know. It's very hard to say, is it getting better?
Okay.
As you say, there is more visibility now, which is brilliant. And there is this attitude of previously you would just grin and bear it, and that's what you have to deal with. And I think that on that side, most people are kind of more aware of it and recognizing bad actors. I don't know if I can say that it's actually got better, but at least it feels as though there are more safe spaces for people to speak up. But I don't think we're at the point yet where we can say, hey, look, it's a much better environment to work in. I would say that academia, astrophysics research, there are areas where people do feel unsafe, and I think it is our duty in the space sector to improve that.
Okay. Wow. Yeah, I think it's, as you say, probably it's a cultural thing, so it takes time, unfortunately.
It does.
Inevitably, because you need to change people behavior.
And I think it's one of the things I wrote in that paper, which is, as a scientist, but also a former teacher, I love doing public engagement. I go on the TV and I'll talk about space, and I want the barriers to participation to be removed. But I feel very strongly that we shouldn't just do outreach, and we shouldn't just tell people how great space is whilst not doing anything about the barriers that make it difficult to retain, underserved people as well. So I think, if personally, like, as someone who did a lot of outreach in my PhD, I also did a lot of advocacy for diversity and inclusion, because I don't want to tell a young person to come and work in a sector that I know is particularly, if this person is disabled or something, or a person of color, like, they're going to have a harder time simply working in this environment. And so for me, I think it's really important that if you're advocating for, these people to join, if you're singing the praises of science, you also need to say, well, how do we make these structures of science better for people too?
Yeah, thanks for everything you say here. And you just mentioned you do, because I saw you on BBC or also on YouTube, so you do a lot of these outreach activities. Probably, but this is my impression, you feel at ease, quite natural. Is that the case, or you still or the first time you were very nervous, I don't know, talking to some unknown scientist or with a camera in front of you?
Yeah, it definitely gets less nerve-wracking. I think I go back to the fact that I trained as a teacher before I did anything else really in my career, and I think if you can get a bunch of teenagers on your side that don't want to be in your classroom and you can convert them to physics, that's a lot easier than talking to a BBC journalist who was really interested in you, So I think that really helps. But yeah, it is scary. You know, I've done speeches in front of lots of people. I've done live TV, live radio. I think for me, the main thing that I know is that if I've prepared enough on the subject, I know I'll be okay. It's when it's something that I've been asked to talk about that I haven't done my homework, you know, that's when I get more nervous, because I'm like, what if I ask something I don't know about? But actually, when I do things with the BBC, etc., the producers are always really good at giving me what topics I'm going to discuss. And also, I know that, like, I know more than the public on this. Even if I don't know the exact specifics of that question, it's about being able to frame your answer so that it's like close enough or like tangential. I think in the UK politicians do it a bit where it's on purpose to manipulate the interview, where they'll answer a slightly different question. But I think in science we can do it where you say, oh, I'm not so sure about that particular thing, but I'll tell you how it works in my part of space. Something like that. So those instances where I know a little bit less, that's how I go about it. But honestly, it's also about being truthful. You know, if they ask me to talk on the radio about something that I don't know much about, like one time the BBC rang me a few years ago when there was a real big cold snap in Scotland. And all the ponds in Glasgow had frozen over, all the lakes in the public parks. And there was also a very high profile thing at the time where a really sad story where 5 children had been standing on the ice in, I think, Birmingham, and had all drowned because the ice had been too thin. And at this point, it was still really icy here. People were going ice skating on the parks here in Glasgow. And BBC Scotland said, could you know, you're an earth scientist, come and talk to us about ice. And I was like, I think this is really important, but I think this is not my expertise. This is also a really emotive, important topic. You know, 5 children have just died. I am not your person. Like, you need to speak to an ice expert. Yes, I have a PhD in earth science, but it's about Mars. And yes, there's ice on Mars, and I could probably talk about that, but I can't really talk about the chances of ice cracking with a person under it in any way that makes me feel like I'm doing a duty as a scientist to the public. So I think a big part as well is knowing what your expertise are and backing yourself to say no as well.
Okay, so they have your number, and they regularly call you. It's like
yeah, they do. It's quite funny. It's journalists is what I've learned. Journalists are quite lazy, and this is no sorry, if that sounds terrible.
Okay.
Like, they get into habits. So and what I found is when you have worked with one journalist on one story and you built that relationship up, they'll often call you up when it's something similar. So I often talk about space on the TV and radio. It might be meteorites, but it might also be astronauts, or it might be missions that going out past Jupiter. I talked about one, etc. So, or I talked about the Apollo missions once, and it's I guess they have a thing of, well, if you know about space, you know about all space. And whilst I'm not an expert in astronauts or in Jupiter, these are areas that I know easily how to go look it up, do my homework for an hour or so before I then talk to them about it. You know, they'll always give you a bit of notice. Or indeed, if I don't have time, you know, one time the BBC rang me, I was actually on a ski lift up a mountain, and they said, can you come and talk to us tonight on telly? I was like, no, I'm in the snow. But yeah, it's great. And I do feel very lucky, but I also, kind of going back to what we talked about before, I also think it's really important to give other people these opportunities too. I'm really aware that, like, whilst I am a woman, like, I'm a straight, cisgendered woman, from like a, you know, middle-class background, like, I've had a lot of privilege, and I do think it's really important to give other people these opportunities too. So I do try and do that where I can, you know, if I'm not available, or, you know, it's something that I know someone who's more of an expert than me, particularly if they're more early career or they're from an underserved background, I will say, look, hey, here's the number of my friend who can talk about this better than I can, because it is obviously a privilege also to be able to get to go on telly. But also, I know it's not for everyone. Some people would just be so nervous that I wouldn't ask. I wouldn't think, oh, you should do that, because it'll get them out their comfort zone. But I've had other friends where I've put them forward who've now done it lots of times since, which has been great to see as well.
Okay, cool. And how was the first time? I mean, did they call you randomly or someone referred you to?
Sometimes, so it's different for different, sometimes they found me through Twitter. Before Twitter like
Ah,
imploded like it is now, I would often, so for instance, you know, we talked earlier about the pig vomit toxin
yeah.
story that makes pigs throw up. With that, I just did a really long Twitter thread on the day that the paper was published, and it got quite viral on Twitter, and then the journalist for the BBC just like slid into my DMs, literally. So sometimes, you know, I found Twitter was brilliant for that, and it's such a shame now that it's become not it's not such a positive space for scientists. So I've really tried to distance myself from it, to be honest. It is why I'm trying to use LinkedIn a bit more, but I feel like there's not quite the same reach beyond your network on LinkedIn as there is on Twitter. So it's interesting to see what'll happen now and what's going to fill the gap. Like people do Instagram and TikTok.
Yeah.
But I find it so much harder to edit videos. It takes so long compared to just firing off a tweet with some GIFs. And it's sad that we've lost that space for the world, you know?
And this is something now you just inspired me for this question is the power of social media. How do you think now this is my view, they are as powerful as publishing a peer review paper, is how you sell it. You need to be also good in communicating. What do you think?
Yeah, completely. I was saying to a friend the other day that I also feel really lucky that I did my PhD when Twitter was still such a powerful tool, because I made so many of my like now really good friends in science through Twitter. You know, I'd go to conferences, you'd use the hashtag and you'd meet people that way. And now new PhD students, new researchers don't have that opportunity, which is a real shame. But as you say, beyond that, I do think it's brilliant to see what people do, particularly Instagram, TikTok, YouTube. And I think, the downside is it does take a really long time and the algorithms are kind of brutal. So you have to really post a lot. And they're so particularly now with Instagram as well, there's a real bias towards video and you have to be slick. And I honestly, I've just not found that it's not as easy anymore, because it does take so long to edit, and unless you're posting really frequently, your engagement just goes really far down. Then you're only really reaching your mates, which, you know, I can just tell them about it without having to spend ages and ages editing a video. So I have so much respect for friends and colleagues who are doing science communication videos, because it does take ages. So yeah, but I think it's so important.
And so what about after Twitter? What will happen after X? What do you think? You say LinkedIn, but do you envisage we will use TikTok or Instagram? Don't know.
So I think there's some brilliant stuff going on TikTok and Instagram for sure.
Okay.
And YouTube as well. Like I say, I just don't think it's for me, because I just don't have that skill in video editing, or at least the time for how long it would take me to do these things. I thought about it for a while, but I like Instagram for doing pictures and stories and things like that. But personally, it's not for me. But there are some brilliant people out there. There's a woman here in Scotland who does like she's like Scottish geologist or something. It's her Instagram, and she does amazing, like really fun.
Scottish geologist, okay.
Yeah, it's so good. She just like stands, she'll be like, "Hey, what's happening?" And she'll just tell you about the rock in front of her. And I think now she's now working, I think she's now full-time just doing that and just getting the public excited about rocks in Scotland, which is pretty brilliant.
Wow. So you are based in Scotland. I read, I don't know, some article, I don't know, it was an interview where you say you have to travel almost 10,000 miles to visit your mom. So where are you originally, or did you grow up?
No, so my mum, when I finished high school, my parents moved to Australia. So that was back in 2010. So I grew up in Newcastle in Northeast England. But yeah, so as an adult, my family were over in Oz.
Okay.
So it was particularly hard in lockdown, actually, because my mum was so far away and she couldn't fly for so long. So I think we went about 2 years without seeing each other.
Okay.
Because of that.
So were you thinking talking about lockdown, or probably there was a moment during your master or PhD where you say, no, I want to give up. It's not my career. It's not for me.
Yeah,
And
it was really tough in lockdown. It was hard because everything was taking longer. You know, I got a little bit of extra funding, but only for about 3 months. But it took a lot longer than that to actually the labs to reopen. So yeah, it was really tough. You know how we were talking earlier about how much I love graphs and charts and things? I got like very obsessed with the data that was coming out about COVID. Like every day there was new data on where the cases were and how many deaths there were, etc. And I think looking back, I was definitely not well. Like it was definitely like an anxiety thing, but I felt this like real pressure of I'm a scientist. I need to understand the risks here. And I got really obsessed with that for a long time and felt like, what is the point in my PhD that's all about Mars when there's this really awful virus? So yeah, I would say it was really tough. But I think it was tough for everyone, you know?
yeah,
Whatever your situation, looking back it's just amazing we all got through it, to be honest.
yeah. And how important do you think was the social aspect of university, especially in the UK, where I think compared to Italy, for example, I think it's a completely different mindset, in a positive way, yeah.
And I think that's again, I was lucky in a way that lockdown happened in the third, fourth year of my PhD, so I already had a cohort of friends. But people who started their PhDs in 2020, it would have been even harder because you'd have been in a new city potentially, and you might not really know anyone, and you would not get a chance to have that. And so yeah, it was really, at the time at least, there were other people going through the same thing. My flatmate was doing a PhD as well in the same department, so you know, you at least had that knowledge of someone you were close to that you could talk about the trauma with, basically.
Hope you both also she go through the end of her PhD.
Yeah, she did. And we graduated together on the same day.
Okay, perfect. Perfect conclusion. I think, Áine, honestly, that was my last question.
Okay.
So thanks again for giving an hour of your time for the audience here. And yeah, I really hope I enjoyed the conversation. I hope people who will listen to this will find useful in terms of not just the science bit, but everything else around the life of a scientist. So thanks again, Áine. And yeah, I will see everyone for the second episode of this series. Thanks.